Now in our next couple problems, we're going to look at how could I eliminate having to check this 16 times? What are some ways I could do to find the answer so I don't have to check it 16 times? One of the ways is we're going to use what are called the upper and lower bound tests. First off, the lower bound is what happens when I use synthetic division and my last line of my division is alternatively non-negative and non-positive. That is, it flips from positive to negative, and if you get a 0 in there, that can count either way. That would be your lower bound. If I put a positive value in here and my last line of my division is always non-negative, so 0 or higher, then that's my upper bound. So if I apply that on this example, so here's what happens. I want to determine an interval for which all the zeros of f of x must lie. I want to explain your reasoning using the upper and lower bound tests, then find all the real zeros. Okay, let's start with our possibilities. Let's do p over q. So I'm going to say plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now, I know I want to eliminate, maybe I don't have to look at 12. So I look at my graph here. Let me blow this graph up. And I want to pick, it looks like my graph keeps going up at this point. Whoa. So I'm going to pick a point here. So that looks like this is 6. So I'm going to, a little bit bigger than 6. I'm going to go 7. So what I'm going to do here is I'm going to let x equal 7. Which doesn't eliminate much. So x equals 7. So I'm going to go 7. And then it'll be 1x to the 4th, negative 4x to the 3rd, negative 11x squared, negative 4x, and negative 12. So if I bring down the 1, 7, so I get 7 minus 4 is 3, so I get 21. 21 minus 11 is 10. 10 times 7 is 70. So I get 66. And if I take 66 times 7, I get 462, which gives me 450. Notice all my answers are positive. So what that does is that tells me 7 is my upper bound. I don't have to check anything beyond 7. Well, that doesn't eliminate much, does it? The only thing it does eliminate positive 12. So I don't have to check positive 12. Now let's look at my lower bound. And once again, I want to pick a number over here that's in the lower. So I'm going to go 1, 2, I'm going to go 3. So I'm going to check with x equals 3, negative 3 for my lower bound. So x equals negative 3 would be my lower bound. So I'm going to go negative 3, let's try 1, negative 4, negative 11, negative 4, and negative 12. So I bring down the 1. 1 times negative 3 is negative 3, so I get negative 7. Times negative 3 is 21, so I get 10. Times negative 3 is negative 30, so I get negative 34. And negative 34 times 3, a negative times a negative is a positive, so I take 34 times 3. And I get 102. And 102 minus 12 would be 90. Notice how it goes. Positive, negative, positive, negative, positive. So that means I don't have to check anything that's less than negative 3. So that does eliminate a few of them. So I don't have to check negative 12 or negative 6 or negative 4. And I know negative 3, I just checked negative 3. So I know negative 3 is not a root, so I don't have to check that anymore. So now I eliminate some of my negatives. So now let's go back and let's actually find the real roots. So it kind of looks at my graph. When I look at this one, looks like it crosses at negative 2, doesn't it? 1, 2. So I'm going to see if negative 2 is a possible solution. So I'm going to see if negative 2 is a solution. So I'll go, let me change pen colors here. So I go negative 2, 1, negative 4, negative 11, negative 4, and negative 12. If it is a solution, I should get 0 for an answer. So bring down the 1. So I get negative 2. So it gives me negative 6 times negative 2 is 12. So I get 1 times negative 2 is negative 2. I get negative 6. Oh, I get 12. I get 0, don't I? So x equals negative 2 is one of my rational roots. Whoops. I wanted to highlight that for you, not cross it out. Now let's take a look at my graph for my other positive ones, and I'll try 6, it looks like. Looks like it crosses at 6, doesn't it? 6 is a possibility, isn't it? Because here's 6 right here. So let's try my synthetic division with 6. I don't like yellow. So let's try 6 there. So bring down the 1. 1 times 6 is 6. I get 0, 6. I'm not going to get that, am I? Did I make a mistake here? Or did I miscount? One, 2, 3, 4, 5, 6. Oh, I can't multiply. Sorry about that. 0 times 6 is not 6, is it? 0 times 6 is 0. Bring down the 1. I get 6, and then I get 0. There are your two roots. Two rational roots are negative 2 and 6. And now I'm back to a quadratic. So then my other ones would be x squared plus 1. So that would give me complex roots, doesn't it? I want to find all the roots. Oh, just find the real zeros. That's all I had to do. So my zeros are negative 2. Whoops. X equals negative 2 or x equals 6 are your real roots on the number line.